Cryptographic hash functions are fundamental building blocks that are used within many different cryptographic algorithms and protocols, and they do have a number of very important applications in the context of information security. So some of the more common algorithms that are known to be cryptographic hash functions include things like MD5. It's probably one of the most common ones out there. MD5 also has some predecessors, namely MD4. There's also a successor to MD5 known as MD6. But basically, MD5 is among the more popular ones. There's also SHA-1, Secure Hash Algorithm 1, and also SHA-2 as well, or some people call it SHA-256, and so on. And there are also some lesser-known instances of cryptographic hash functions. For example, Blake or Skeen. And actually, Blake and Skeen are finalists in a competition for predicting or coming up with a new version of SHA. There's actually a contest now to come up with a SHA-3. And in particular, Blake and Skeen are finalists in that contest to come up with SHA-3. Now, cryptographic hash functions are used as building blocks in many different applications. For example, let me give you a few instances of applications. So, digital signing is probably one of the more common ones. Digital signing. Message authentication. So digital signing, message authentication. Pseudorandom number generations, PRNG. Password security, and we'll probably do some more videos on password security since it's such an important topic, but password security, a lot of password security schemes do use cryptographic hash functions. You could even use them for encryption, although you can't directly encrypt something by applying a cryptographic hash function to it. It turns out that there are some ways in which you can use cryptographic hash functions as building blocks for encryptions. So first of all, let me look at the more basic question. What is a cryptographic hash function? So to begin with, it's a hash function. Obviously, it's got the word hash function in it. And what is a hash function? A hash function is basically just a function that can take a particular input, and we typically call that input the message. Okay, so we have an input which is a message. Okay, and the hash function basically applies a set of mathematical transformations to that input. So basically, imagine this box here represents mathematical transformations, so various different bit twiddlings and so on. Okay, mathematical transformations. And at the end of these mathematical transformations, you get an output which is typically called either a digest, it's also sometimes called a tag, it might also be called a hash, and so on. And actually the words message and digest, if you see the words message and digest, that's actually what MD stands for in MD5 and MD4. It stands for message digest. Okay? Now, the interesting thing here is that the message itself can be of arbitrary size. It can be really, really big and really long. It doesn't have to be, there's no restriction on how big it is. But the digest, the output, the tag, the hash, is going to have fixed length. Okay, and it's typically going to be shorter than the input. So it's going to have a fixed length output. And it doesn't have to be shorter, but in general, if you can have an arbitrary size message. You may have a message that's very big, but a tag that's relatively small. Okay? And in general, the function here, this mathematical transformation, is also what's known, it's called a deterministic transformation. Deterministic means that if we put the same input in, you'll get the same output. So deterministic. Okay? Now, hash functions themselves are used in many, many computing applications. I mean, and these are what I think of as basic hash functions. For example, a hash table uses something called a hash function. And I do want to mention and stress here that the kinds of hash functions that are used for something like a hash table aren't necessarily cryptographic hash functions. The qualifier cryptographic, this qualifier cryptographic, is very, very important, and it actually does imply certain things about the properties that you need. So for a hash function to be a cryptographic hash function, it has to have certain additional properties. And let me actually give you maybe some intuition about these properties, and I can make that more concrete in the subsequent video. So to begin with, the hash function has to be computationally efficient. In other words, you have to be able to apply this transformation efficiently. It can't take a long time to apply that transformation to the message. It has to take a reasonable amount of time to get the output from a given input. Okay, the second thing is that you generally want a cryptographic hash function to hide information about the input. To hide information. So well, what does that mean? Well, what that means is that from the output alone, you should have a hard time inferring anything that's maybe interesting about the input. And I don't just mean the actual input itself, I also just mean any part of the input, like knowing whether the least significant bit of the input is a 0 or 1, or even knowing whether there are an even number of zeros or ones in the input, and so on and so forth. Really just any kind of interesting information about the input should be hidden when the hash function is applied to that input. In other words, from that output, you should not be able to glean that other information. Okay, the third thing you kind of intuitively want is you want the output of the hash function to be well distributed. Well distributed. And by that I mean that no particular output value should occur disproportionately often. Okay? Each output should occur roughly the same number of times. You don't have to have it be exactly the same number of times, but it should roughly be the same number of times. Okay? And with these properties, what we're really saying is that the output of a hash function really kind of looks random. It looks random. Okay? And I realize I'm being somewhat vague in what these notions mean, but I guess intuitively you can think of a cryptographic hash function as really the mathematical equivalent of a blender or a meat grinder. You can take inputs and apply mathematical transformations to them such that the output looks more or less unrelated to the original input. So what I'll do is I'll end this video right here. In the next video, I'll switch gears a bit and talk more specifically about some concrete security properties that you might want in a cryptographic hash function.